We've taken cheek swabs from 3 volunteers who were each affected by alcohol in very different ways to see if their genes can explain why.
So how would you be feeling after drinking that glass?
Pretty sleepy. I'd be ready to go to bed, even with my boyfriend kicking me under the table.
Oh, really? Like, it's like an anaesthetic?
Just that. Yeah.
After half pint, I'll start to feel the effect kicking in. My eyes get red, my arms, my neck gets red too.
And how bad are your hangovers?
Oh, it's a continuous headache throughout the day.
Really?
On any social event, I'll go out and I will have easily 4, 5, 6, 7, 8, 9 pints. No real hangover, no real effects.
Helping us to understand these differences is Dr. Ashley Brown from Imperial College London.
Hi guys. Hey, how you doing?
Dr. Brown studies the genetics of alcoholic liver disease.
We can clearly explain these 3 different experiences with alcohol on the basis of genetic variation.
And that's because the enzymes that break down alcohol in our bodies are determined by our genes. Alcohol is first converted into a chemical called acetaldehyde, which becomes toxic at high concentrations. The acetaldehyde is then broken down mainly in the liver by a second enzyme into carbon dioxide and water. These can be eliminated from the body.
So we've got the results. Alice and Joe, you guys have the same variant and you're different to Glenn. So you guys do not get rid of alcohol as quickly.
65% of Eastern Asians and 5% of Europeans have the genes that code for the slow metabolizing enzyme at this first stage, meaning that alcohol stays in their system for longer.
But then we do see a difference in this second enzyme that gets rid of the toxic byproduct of alcohol, the acetaldehyde. And Alice, you have a typical genetic profile for this, so you get rid of it as fast as anyone else. But Joe, this is where you have a variation in your genes that means that you don't get rid of the acetaldehyde, which is what we're seeing right now looking at you.
This is living genetics. This is a great example. And I think, what Joe's body is doing is telling him to stop drinking. And what we see in people with that slow gene is that if they carry on drinking through it for social pressures, despite the side effects, then they are putting themselves more at risk of liver disease.
And it's thought that it's this toxin, this acetaldehyde, produced as we break down alcohol, which makes Joe's hangovers worse than most. But in Glenn's case, his enzymes work normally, so he breaks down both the alcohol and the acetaldehyde at the typical rate. So if his enzymes are normal, how come he can drink much more alcohol than most people without feeling it?
There is an alternative pathway which actually breaks down alcohol by a different method. What's different about this pathway is that it's inducible. There is no limit to the amount of alcohol that you can carry on passing down that pathway.
This secondary metabolizing pathway can be switched on when we drink faster or in larger amounts than the body can cope with. It works like an overflow system. This allows the additional alcohol to still pass through the liver.
So Glenn has induced or switched on this second way of dealing with alcohol.
Correct. It goes from the gut to the liver. It's broken down. It never gets into the bloodstream, so it never has that effect on the brain, which is effectively where we feel drunk.
Does this mean that the alcohol is less dangerous in terms of the effects on Glenn's liver than it would be for someone who doesn't drink that often and that regularly?
Absolutely not. Okay, the alcohol is still being broken down by the liver, and the breakdown products of the alcohol are what's causing the damage to the liver tissue.
So having got these results, I think the thing I really want to know is where does it leave us with our experiment? Xand's been binging a huge binge once a week. I've been drinking a little bit every day. Does this give us any view on who's going to win the argument?
Binge drinking is really not a good idea. You're far more likely to be inducing that alternative pathway, which is going to have the damaging effects.